Hello everyone, the learning content of this lesson is the determination of the three elements of a function. We have already learned the concept of functions and their representation methods before. In this lesson, we will continue to explore the essence of functions. Firstly, may I ask everyone a question? What elements do you think are required to form a function based on its definition? We need a correspondence between set A and set B. Set A is the domain of the function, and set B is not uniquely deterministic, but once the domain and corresponding relationship of the function are determined, the value range of the function will be determined accordingly. Therefore, we refer to the domain of the function and the range of values corresponding to the function as the three elements of the function. As mentioned earlier, the value range of a function is determined by its domain and corresponding relationship. Next, we will focus on exploring the domain and corresponding relationship of functions. First, corresponding relationship. How do you understand the analytical expression of this function from the perspective of its three elements? F. It's just a correspondence. The x in parentheses becomes the equation on the right side of the equal sign through the action of f. That is, the operation form of subtracting the absolute value x minus 1 from the square of x. The second question is to calculate f1 and explain the calculation process. Through the calculation process, we can find that x in the original equation has been replaced with 1. We previously performed an operation on x, but now we are performing an operation on 1. Let's calculate f2x minus 1. We have replaced the x in parentheses with 2x minus 1. We previously performed an operation on x, but now we are performing an operation on 2x minus 1. Please have a good understanding of the corresponding relationship inside. In many cases, the form of correspondence relationship f is a series of operations. The object of operation is the content in parentheses. The values in parentheses must be meaningful to the function itself. Y equals f in fx, which is a symbol of correspondence and can be replaced with any letter. For example, y equals gx and y equals hx. Secondly, define the domain. Let's take example 1. Given the analytical expression of the function, the first question is to find the domain of the function. The domain of a function is the range of values of x. To make this parsing expression meaningful, so in the first part, the equation under the root equation should satisfy greater than or equal to 0. In the second part, the denominator of this fraction must not be equal to 0. To ensures that both inequalities hold simultaneously. This gives the solution set where the domain of this function is x greater than or equal to -3 and x is not equal to -2. Here, we learn a new concept interval. Let a be two real numbers, and a is less than b. We define that the set of real numbers x that satisfy the inequality x greater than or equal to a and less than or equal to b is called a closed interval. The set of real numbers x that satisfy the inequality x greater than a and less than b is called an open interval. The set of real numbers x that satisfy the inequality x greater than or equal to a and less than or equal to b, or x greater than a and less than or equal to b, is called a semi-open and semi-closed interval. Here, both real numbers a and b are called endpoints of their respective intervals. The real number set R can be represented as an interval from -infinity to +infinity. Next, we will present the interval and number axis representations of different sets using tables. It can be seen that points containing interval endpoints are solid points on the number line. If it does not include the endpoints of the interval, it is a hollow point on the number line. Through the definition of intervals, it can be found that intervals are actually a representation of sets of numbers in a set. Let's use the newly learned interval to represent the domain we just calculated. First, draw a number line. Mark the relative positions of -3 and -2 on the number line. It can be expressed as a left closed and right open interval from -3 to -2, and an open interval from -2 to +infinity. Let's take a look at the second question again. Find the values of f-3 and f2/3, because both -3 and 2/3 are within the domain of the function. So based on the corresponding relationship, x can be replaced with -3 and 2/3, and the corresponding function value can be calculated. The third question, when a is greater than 0, calculate the values of fa and fa minus 1. A greater than 0 ensures fa and fa minus 1 is meaningful. so we will also replace x in parentheses with a and a minus 1. You can obtain the corresponding function value through the corresponding relationship. Someone must have noticed that the structure on the right side of fa and fx is the same, so may I ask if there is any difference between the two of them? Fx is the analytical expression of a function. The meaning represented by fa refers to the function value corresponding to the independent variable x being equal to a. They are different. Let's take another look at example 2. Find the domain of the function. The domain of a function is the range of values of x. To make this parsing expression meaningful, the first step is to list all the conditions that need to be met one by one. The second step is to use curly braces to indicate that both statements are valid. Step 3, after solving them separately, take their common parts and represent them in the form of intervals. In the process of doing this question, it is important to pay attention to the rigor of logic and the standardization of expression. Let's take a look at example 3 again. Which of the following functions is the same as function y equal to x? How to determine if two functions are the same? That's right, through the three elements of a function. Define domains, corresponding relationships, and value ranges. And the value range is determined by the domain and corresponding relationship. If the domains of two functions are exactly the same and their corresponding relationships are also exactly the same, then these two functions are the same function. Next, we will analyze from the perspectives of the domain and correspondence of functions whether the following for functions are the same as function y equals x. The y in the question is equal to x, and the domain of this function is all real numbers are. Its correspondence is to map x to itself. Let's take a look at the first one first. Y is equal to the square of x below the root. The domain of this function, it is from 0 to infinity, left closed and right open interval. It can be observed that the domain of the first function is different from the function y equals x, so it must not be the same function. Let's take a look at the second function again. Y is equal to the third power of x below the third root. The domain of this function is also the entire real number r. Let's take a look at its corresponding relationship. First, take the independent variable x to the third power, and then open the root of the third order, which is actually y equals x. This corresponds to x itself, so the second function is the same as the function y equals x. Let's take another look at the third one. Y is equal to the square of x under the root sign. Let's first look at the domain definition. Localization refers to all real numbers r. Let's take a look at its corresponding relationship. We know this function, but we can actually write it as y equals the absolute value of x. When x is greater than or equal to 0, it corresponds to itself, while when x is less than 0, it corresponds to its opposite number. So the correspondence between the third function and the function y being equal to x is different. Finally, let's take a look at the fourth function. The domain of this function is from negative infinity to 0 and from 0 to positive infinity. Obviously, the fourth function is not the same as function y being equal to x. I have drawn a graph where y equals x. Let's take a closer look at the differences between the four functions and the graph where y equals x. First, it can be seen that the image is only in the first quadrant. The second function is the same as the image of y equals x. The graph of the third function is distributed in the first and second quadrants. The fourth function graph, although located in the first and third quadrants, is missing a point. This question tells us that from the domain and correspondence of a function, we can determine whether two functions are the same function. Let's take example 4. This is a practical application problem of mathematics. It is the obligation of every citizen to pay taxes in accordance with the law. Personal income tax, also known as individual income tax, shall be paid to the state in accordance with the personal income tax law of the People's Republic of China on income obtained by individuals. Starting from January 1, 2019, the amount of individual income tax is determined based on the taxable income, tax rate, and quick calculation deduction. The calculation formula is as follows. The calculation formula for taxable income has also been provided. The basic deduction fee exemption amount is 60,000 yuan per year. The tax rates and quick calculation deductions are shown in the table. From the table, it can be seen that when the taxable income does not exceed 36,000 yuan, the tax rate is 3%. When the taxable income exceeds 960,000 yuan, the tax rate is as high as 45%. Let's first take a look at the first one. Assuming the annual tax payable is T and the individual income tax payable is Y, find the analytical formula of Y with respect to T and draw a graph. Firstly, we need to identify the relevant information from the question. The taxable amount and the amount of personal income tax payable can be obtained through Formula 1 in the question. The tax rate and quick deduction amount of Formula 1 can be read out through a table. However, we found that the tax rate and quick calculation deduction amount vary with the different ranges of taxable income, indicating that an analytical formula is not enough, so a piecewise function is needed. So let's combine this table to mathematize Formula 1. The individual income tax amount is Y, and the taxable income is T, so we can obtain the analytical formula of Y with respect to T. When expressing piecewise functions, students must pay attention to the standardization of writing. Corresponding images can also be obtained. Let's take a look at the second question. Zhao Weng's annual comprehensive income is 189,600 yuans. Assuming that the social insurance premiums such as basic pension insurance, basic medical insurance, unemployment insurance, and housing provident fund paid account for 8%, 2%, 1%, and 9% of the comprehensive income, the special additional deduction is 52,800 yuans. How much comprehensive income tax should he pay for the whole year if other deductions are determined to be 4,560 yuans according to law? There are too many names involved in the second question, so we need to go back to the question stem to find useful information. Require comprehensive income tax. Firstly, the taxable income should be determined. The taxable income can be obtained through Formula 2. We will match the conditions in the question with Formula 2. It can be seen that 189,600 yuans is the comprehensive income amount. 60,000 yuans is the basic deduction for expenses. The proportion of various insurances and housing provident fund refers to special deductions. 4,560 yuans refers to other deductions determined by law, and 52,800 yuans, which is a special additional deduction. So, based on the conditions in the question, combined with Formula 2, the taxable income of Zhao Weng can be calculated. How should personal tax be calculated? We need to rely on the mathematical model we established in the first question. The range of the independent variable obtained through calculation is 34,320 yuans. Find the corresponding relationship. Furthermore, the comprehensive income tax amount that Zhao Weng should pay can be calculated as 1,029.6 yuans. Let's summarize example 4. For practical applications of mathematics, the first step is to extract mathematical information through reading comprehension. The second step is to mathematize the information, which for this problem is expressed in the form of piecewise functions. The third step is to use mathematical models to solve practical problems. During this process, it is important to pay attention to defining the domain. Finally, we will summarize the content of this lesson. In this class, we learned about intervals, which are a representation of sets of numbers in a set. In the learning of functions, intervals are very convenient for expressing the domain and value range of functions, but at the same time, attention should be paid to the different symbols at the endpoints of the intervals. I also learned the three elements of a function: domain, correspondence, and value range. Determine whether two functions are the same function from the perspective of the three elements of the function. In this process, we can also further verify from the perspective of form. To be able to use the three elements of a function to solve practical problems, attention should be paid to the rigor of thinking and the standardization of expression in this process.